and certain. Okay, Abhi. Anything which has space and occupies space is mass. Okay, Abhi. Correct. Then we are going to study about the factors which affect the matter, okay, or the composition of matter, which is related to temperature and pressure. And then at the end, after studying about the different phases of matter, how does the matter change into different phase, we are going to study about the latent heat of fusion and latent heat of vaporization. So all this we are going to study in this chapter. So first thing first, there is a scenario which is at present on the slide. Can you tell me what all sorts of matter you can see in the screen? Just name some items, some things which you can see on the screen right now. This is a classroom scenario. Paper, steel, wood, chair, calendar, benches, blackboard. Right, students? Yeah. Hmm. And what about the lady who is standing? Is she also a matter? Is that lady also a matter? No. How come no, Abhay? Yes, Mehak says yes, Lavanya says yes. Abhay is saying no. Why, Abhay? Can you explain why this lady is not a matter? Composition may be different. It's like it's not going to be the particles, but state of matter is there inside her body as well, and it's physically also a matter. We will understand this when we will study about the definition. Okay, let's see what this picture is asking about. So observe your classroom carefully and make a list of things that you find. Do all these things have mass? You already told me that yes, there is a mass. Then they all have mass. Do they occupy space, students? She occupies some space. Yes, Om. That is why Abhay, the lady which is in the picture, is a matter. Hmm. And plus, do you like, can you tell me what, in how, like which form all the three states of matter is present in humans? Solid, liquid, gas is present in which form in like in our body? Anyone? Wild guess. Solid bones, correct, Abhay? Liquid is what? Liquid blood. Liquid can be water as well. Gas is equal to oxygen. Correct, Lavanya. So all these forms are present in our bodies. Correct. They occupy space. Apart from all these things, something else is also present in the classroom which you cannot see. Is it, students? Is there something else which is present which you cannot see? Anybody want to guess something? Okay, gas. Air, yes. Intelligent students are there. So whatever present around us is called matter. Okay, everything to which we are surrounded by is matter. Now let us see a few more examples. These vegetables, fruits, desert, flowers, water, air, sky, stars, all are matter. Now what is not a matter? We know about the matter. We are studying about the matter from very primary sections, and we know that all these things are matter. But if we ask the opposite question, what all things does not consider as matter? What are they? Sound, light. Hmm. Sound, light, heat. So what are they? What are they if they are not matter? Yeah, this we got it. Which does not occupy mass and space. So, but it is present, no? It is visible to us. Sound, light, and heat. Can I say they all are the forms of energy? They are the forms of energy, isn't it? Hmm. Plasma is also a matter, correct? Correct. So it is the fourth state of matter. Hmm. So they all are the forms of energies. Okay, so classification of matter we are going to see. So simply, first we write a definition of matter and then I'll tell you about the classification of matter as well. Okay, so everybody, you can write the chapter name. The first uh, topic is matter. You can ask a question or you just can write what is matter or matter. So already people have answered this to me. Anything that has mass and occupies space is called as matter, which you can perceive through your senses or you can see it. Now, while writing now, you can guess the things which I'm asking to you. Have you ever wondered why does traffic jams happen on road? You must have observed this one or you must have an experience of this one that road is filled with jams. Sometimes it is struck. Vehicles are struck. Why so? This prove that these vehicles are matter. Your explanation will prove this. Yes, Abhay, it is. Hmm. It's better if you can give me examples. We all know that these are the five forms. Plasma is there, one is also there. But if you are able to give me any examples, then will be better. But before that, just tell me why does traffic jams happen? Is it related to matter something? They occupy space on road, correct? So all the vehicles occupy space on road and it leads to road struck, okay? The vehicles can't go forward, can't go back, they are struck. So it explains that every matter on the earth need space to exist. Right, everyone? And all the signal how come? In relation to matter. Yes, ma'am. Nothing, your name is nothing. You have any name? Okay. Okay, so next done this one definition. So let's prove that air has mass. You can see when we inflate something, any object with the air. So it is proved that football has the mass in it. Or any ball which we are inflating with the air, that consider that everything, like every object has some mass. So this we have measured the mass. Okay, so mass, consider everyone. I would like you to think about this concept that mass is actually the composition of particles or yeah, composition of particles which are present inside the object and we can measure it. Okay, so composition of particles present inside an object really proves that the object has a mass. Every matter has a mass. Like balloon. Hmm. Like balloon. Which gas has been in, which gas is present inside the balloon? Anyone? So
Helium.
I am, yes, helium, correct. Okay, everyone. So mass is the composition of particles which are present inside the matter. The matter can be anything. Here, for example, we have taken the football. So can I say that mass is that unit by which we can measure any matter. Am I right if I say so? Mass can measure the matter or not? Yes. Okay. Now there is very tiny concept after this mass. Okay. This you have done. Now, what is mass? And it has been compared to very interesting topic, very tiny topic. Let us see. So mass, we know that it is a physical quantity which is expressing the amount of matter present inside a body. Now, very similar term, kind of, is what is weight? The formula is written here that it is a mass times gravitational acceleration. But can somebody explain what is weight? Weight and mass are same. Anyone? Okay, Dhaneshri. No. But what is weight then? You know, our weight can be different, right? And it depend upon the places we are going to, even the planet. If we consider different planet, our weight will change, but mass will not change. Mass is a composition of matter present in something, in an object, right? It's a physical quantity. But what is weight? How does the weight contrast the mass, or what is the comparison? Mass remain constant, weight can differ. But what is weight? Actually, you can depict the definition through the formula. Weight is not a physical quantity. It is actually the force which is exerted on an object by the gravity. Okay, so Earth is exerting that force on an object. That is weight, a particular amount of force. So mass is a physical quantity and weight is a force. We can calculate the weight in newtons. The measure of the force of gravity acting on an object mass. Yes, to be precise. So let me give you the definition as well if it is here. Examples are there. Okay, everyone. So I want you all to write the mass and weight comparison. I am writing it for you and you can write it down as well. Sometimes it can ask, sometimes it doesn't. It's a small topic, but we can read it, learn it. So first, so you can write the definition here itself and about the weight. So everyone, I have given you numericals. You don't have any doubts in that one? Like anybody hasn't done that one? How would you know that you have written the correct, like you have solved the correct answers? You're not asking about the answers as well. So weight is variable. Mass remain constant. Measured. Hmm. So after in the end of this class, now I will provide you with the answers. If someone has done the numericals, he or she can check their answers. How mass remain constant? It depends upon the matter. Okay, Abhay. It's not about that for every matter it remain constant. Yeah, for every matter it depends upon the matter, regardless of the location. It is constant. Okay, so you haven't answered about like you have done the numericals or not. If not, then I'll not give you the answers. No, why should I waste energy in giving the answers then? That day you people have like taken the screenshot, taken the photos of numericals, remember? But you haven't done. How come? When you have done writing this one, just let me know. I will go further.
Ma'am, done.
Done? Okay. Everyone, I'm going further now. Now there is one more concept apart from mass, weight, there is volume. Okay. There is volume. So this is one of the physical quantity as well. So amount of gas and oil present in respective containers. Mind this, okay? So amount, the measurement of a gas and oil which is present in certain containers can be given by another physical quantity which is known as volume. You can write about volume as well. The space inside the container that is occupied by matter is its volume. Majorly, we use this term for the liquids and for the gases when it is being filled inside the containers. Sorry. Done, everyone?
Yes, ma'am.
All right. Now we are going further. So this I have already asked you that everything is not a matter. Heat, light, sound, these are different sorts of energies. Okay, so now we are going to start with the physical properties of matter. Okay, but before that, you can make a flow chart writing about the classification of matter. Just write the heading classification of matter like this and just make a flow chart down like this. Oh God, where should I write? Okay, so I'm writing here, students. Just give the heading now, classification of matter. It's being two categories there are physical and the chemical properties. Now, who will tell me about the physical properties and about the chemical properties? Like, what are they? Just I don't want with respect to matter, but just tell me about it. Any definition? Pure and impure matter. Okay. So we are not talking about the solutions, Abhay. Solutions can be pure and impure. Matter can also be pure and impure, but we talk that one regarding the solutions when we talk about the matter. Yeah. So now tell me physical and chemical. What do you mean by physical property? What do you mean by chemical property? Are they both different? If they are different, how are they different? Come on, everyone. Are physical properties reversible, students? Now everybody will like, right? Yes or no? So they are reversible. Like if you stretch a band, you can make the band go to its initial position, initial shape. So that is physical property. And if I provide heat to the food, to the vegetables I brought from the market, can I reverse them and form into the raw vegetables again? No. Yes, if because I have, it is a irreversible change and it is a chemical change which can't be reversed down. Okay. So similarly, matter also have their physical properties. Now we are going to see every physical properties. We will prove them through certain experiment. Okay. So first we will see the experiment and then write about the physical properties. Now you can give the heading physical properties of matter. Okay. Okay. So there is an experiment I will show you first. Hmm. So in NCRT, there is an example which is being done with a potassium permanganate, also known as KMNO4. This is a potassium permanganate and this is a beaker filled with water. Okay, students. Now, in that experiment, it says that in this beaker, they will put a small amount, or like a crystal of, wait, it's not working with the, so this is a beaker and then we have put we put some amount of KMNO4 inside this water. Now we can see some change happen, like the water turn into red, this pink and purplish color. Now we take some sample of this pink purple color water into a tube, and then what we'll do, we will fill this tube with this potassium permanganate solution, and then we are going to pour this solution into a next beaker which already have 100 ml amount of water in it. Okay, now we are taking this 10 ml solution and we are putting this. Now again we will do the same thing. We are going to take a beaker and when we are going to pour the same solution from the second one. Now the third one, we will see the same thing. Can anyone tell me why this pinkish solution is attaining this color again and again? Does that color remains the same from the first one to the fourth beaker? Or it gets lighter, blur? It's still not darker, no? This is the first beaker. It's a darker thing. And then in the three beakers, they have the light solutions. Because particles are going lesser. Okay. Okay, any other answer want to put there? Inputs, particles of matter are small. Particles of matter are small. That's correct. Now we have taken even one crystal of amount of particle are different. How come? How come, Lipika, we are taking one element like potassium permanganate we are taking. So the crystal of remains same, no? Crystal are being of potassium permanganate only. So particles can't be differ. We are taking the same amount in each beaker. In each beaker, okay. Let us see that. Okay. So, yes, of course, there are tiny particles in one crystal. Yes, correct, Lavanya. See, we are taking a small particle of a potassium permanganate. This small particle itself has millions of particles present inside it. Okay, so whenever in each beaker, no, they are spreading these particles up. So in each solution, you can see first one is totally darker shade. and then we pour the second one with the diluted solution, then it get lighter. Again, it's get lighter, lighter, lighter. So yes, it is correct that particles become lighter, like particles become uh, different in each beaker. That is also correct. In certain to a certain point, it is correct. But the main point is that only that particles of matter are so many and they are so tiny also. So this one is the proof for the first property of matter, that matter is made up of very, very tiny particles. And those particles are known as what? Anyone? We know this one, right? In human body, we call them as cells. And in non-living things, we call them as atoms. Correct, Abhay. Thank you for answering. Now, everyone, you can write down the first physical property. Yes, yes, atoms, Maggie. Thank you. Lavanya, atoms, correct. So you can write down the first property. Mm. This one is going to be our first property, students. Matter is made up of tiny particles. The particles which make up the matter are atoms or molecules. Now, who will tell me what is molecule, students? So, physical nature of matter or physical property of matter, first is matter is made up of particles. You can write down, and they are so tiny, so small. First number. Can anyone tell me any difference about group of atoms? Okay. So, water is a molecule, right? Do you know about the compound, students? Yes, okay. Anybody know about the compound as well? Atoms, molecules, compound, elements, atom, molecules, and compound. Compound, anybody knows? Okay, no. All right. So for the first property, everyone write this one, that matter is made up of tiny particles and these particles are known as atoms or molecules. Tell me when you have done, students. Done. So I'm going further now to our second property. Okay. So our second property is the particles of matter have spaces between them. You can write about this property and then I will prove this with an experiment. Particles of matter have space between them. Okay. So now we had taken 100 ml water in a beaker. And now we have marked the level of water, add this 50 gram of sugar into it. And we already know that this sugar will dissolve, right? By stirring with a glass rod, it will dissolve. Does it change the volume of water as well, students? Because that what the sugar compounds are being dissolved, right? Inside the water. Will it change the volume of water? Yes, it will change. Anybody else want to? Lavanya, no. Abhay, yes. How come, students? It will not change the volume of water. So in the experiment as well, you can see we have marked here, right? Right? We have marked here that it was before volume was this much only. And after dissolving the sugar, this much volume is there. It doesn't extended. I'll tell you. Does anyone, like Lavanya has said no. So Lavanya, what is the explanation behind this? Can you tell me? You want to put your input in this one. Why does the volume? Yes, actually, correct. Excellent, Lavanya. So, everybody, you already know that because we have seen this, right? solid has the particles which are so much close to each other, right? So much close to each other. They have very little space. There is space, but they have very little space. Then when we talk about the liquid, they do have the space in comparison to solid. They do have much space. And in the gases, we can see there are much spaces in between them, in between the particles or the atoms. So what happened when the beaker, inside the beaker, the water was there. So water has some spaces, no, in between. So when we dissolve, when we try to dissolve the salt or the sugar in between the particles of water, so that sugar particles will come in between, or even the salt if we are taking, they will come in the spaces between these sugars, between the water. So that is why, and get dissolved inside the water. So it will not increase the volume of water, yet it get dissolved inside the liquid. Okay. One more thing I want to ask with this. Does the particles of a matter plays a significant role in forming the shape of certain materials or certain matter? Does the particles of matter which are present inside each of the matter is responsible for forming the shape of certain matter? Yes. Okay. Correct. Yes, yes. And now tell me one more question. Is highly compressible, or which matter is highly compressible? Compressible, you know, we can easily put the pressure on.
And gas is highly compressible.
Yes, correct. Why so? Why? Guess who am I? Tell me your name first.
Ma'am, may I tell?
Yes, you can tell, Lavanya. Tell.
Ma'am, because the space between the particle of the gas is loosely packed.
Correct. Is loose, right? If you are saying that particles are if you are talking about the packaging of particles, then you can use this word that the particles are loosely packed. Now you can use that there are so much space in between them. That is correct, Lavanya, because particles are having much more space in between them. Then, of course, and can you tell me any example where you can compress the gas apart from gas cylinders? I know you are going to give me that answer. So, and force of attraction is minimum. Okay, Om. Any examples where you can compress the gas inside the liquid? Okay, now inside the liquid, you can compress the gas. No one drink cold drink, soft drinks. No one drink that. Have you ever observed that there is a gas which has been compressed inside the liquid or inside your cold drinks? Students, answer. Hmm. So you can compress the gas inside the liquids. Okay. So from this second property, we are going to write a certain relationship. Okay, Maggie. One statement we will add on. Please write it down. I'm dictating that statement. You need to write the extent of spaces. The extent of spaces varies in different states of matter, where you can see the solid has a maximum, liquid not that maximum, and gas oh sorry students, you can write this extent of spaces, relation. It do depends upon the spaces of particles which makes up the whole matter shape. That is why we always say that solids are compact, right? And liquids are flowing and gas are randomly moving here and there. Okay. Now we are going further to the third characteristic or third property or third physical property of matter. Okay, so I'm changing the slide, everyone. Now, the next one is particles of matter are continuously moving. You can write this down first. And this is generally C. So then this chapter is not that difficult. But difficulty becomes when the questions asked from these chapter become little bit confused. Like the question might comes from this chapter which can confuse you. But if you know the concept, if you know the statement like any relations, then you can do the correct answers. Okay. They will not directly ask you, tell me which are the 3 or 4 properties of matter. They will not directly ask you because it's a science, okay? So that is why it is important to prove these properties with the experiment. So generally they can ask you about the experiment as well in your NCERT or in any book you are learning this chapter from. Okay, they can ask the question from the activities as well. So particles of matter are continuously moving. First tell me, every matter, even us, if we are moving, then we are performing which kind of motion, which kind of energy we are performing, or the motion of that object, like any object which is in motion, is exhibiting which type of energy? Anyone?
Kinetic energy, ma'am.
Yes, kinetic energy. Why do people have certain different names? Why you are not saving your names? Why this kind of stuff you're writing with your names? Your mom and dad has given you very special names, no? Please write your names, no? It will be good. Okay, so yes, kinetic is the correct answer. Kinetic is the correct answer. Who has given the first answer as well? So, okay, so every matter which is in movement or which shows the motion has the kinetic energy. But now tell me, if the energy is stored in the matter, now which type of energy is exhibited by those matter which are storing, keeping the energy to itself? What is that energy possessed by certain matter called? For example, if we take the example of a waterfall, okay? So water, before it falls from the mountain, it is like not coming, no? It's not in motion. Like it's in motion, but it's a kind, okay. Dam is the correct example for this one. Dams, when the water is being stopped to flow. So, but still that water has the energy, which is in a stored form. What is that energy called? And whenever the dams got open, then water get fall. It comes with too much energy, with too much motion. That is kinetic energy. But the stored form of energy is what? Anyone? That is called the potential energy. Potential energy, which has the capability to perform motion. That is called potential energy. All right, students. So there are 2 types of energy, kinetic and potential. Okay, so now we got this answer that every particles in a matter are continuously moving and they show the kinetic energy. Now we will prove this one. Okay, students. So many a times question will comes from this particular property. Let us see if we have this. Okay, so potassium permanganate particles spread through the water particles and mix up their own without stirring because they are moving or they are in motion. Yes, it can be the answer. Like if we put the ink inside the water. So ink started getting what? Spreading inside the water, and the water gradually get into blue color, right? So that means that these particles are in motion. that without stirring, they keep on changing the color. Om, you can, yeah. Okay, next one. The movement of different particles among each other so that they become mixed uniformly is called diffusion. So from this topic, no, diffusion questions can be asked. Do you know what is diffusion? If you have studied the chapter cell in biology, there was a different meaning of diffusion, but it means the same here, but the other meaning is there in this chapter. But first tell me, what do you know about the diffusion? Anyone?
It is intermixing of particles of two different type of matter.
Okay. Yes, correct. Yes, it's a mixing of matter. Okay. Now, okay, Pranit is your name. Now tell me one more thing. Is this diffusion happens in your body as well? Where does this happen? Anyone? Is this diffusion happens in our bodies? Imagine, okay? Now we are inhaling the oxygen, okay? We are inhaling the oxygen. It is diffusion is the passing on or transferring the material or matter from higher concentration to lower concentration. Up till when both the locations or both the places are in equilibrium. Okay, so equilibrium is the goal. Both in the higher concentration and lower concentration must be equal. Same in the ink and same in the potassium permanganate example as well. So what happened when we are inhaling the oxygen? Actually, our environment has maximum amount of oxygen. We will consider our environment as the higher concentration of oxygen. But as we inhale, that oxygen will go into the lower concentration, like our lungs, like our nose first, then our lungs. So this is where diffusion happens in our bodies when there is a movement of gases from higher concentration to lower concentration. This you must have studied in the cell chapter as well. Now similar thing happens here as well in if we talk about the matter. So this movement of different particles like this diffusion can happen in every state, solid, liquid, gas, right? Now, first, I want you to write a diffusion definition, and then we will study some of the situation where diffusion happens. You can write about the diffusion. And here in this chapter, diffusion is nothing but intermixing. Same what Pranit has said us, like answered, that intermixing of certain matter with each other is diffusion. Remember that you need to write uniformly. Uniformly depict equal. So you need to write the uniformly word. Any other example you can observe in your homes? Maybe an example of a perfume. Yeah, one example I want to. Okay, after this, you can write one more thing and then I'll ask one example. The movement is least in solids because we already know that solids in solid the particles are so much closer together, so they are actually moving but they don't show the overall movement, they just vibrate on their own position like up and down. Okay, so the movement is least in solids and more in liquid and most in gases. Now, what is the difference between perfume and deo or DEO, right? Is there any difference? Anyone who apply both? Usually people who are involved in sports activities na apply deo. They do not apply perfume. Perfume they do apply but in occasionally. What is the difference between them? Perfume and deo. Anyone? You know? Hmm. Perfume is for long term. Okay, Abhay. Okay. If you can relate the answer with diffusion, can anybody try this answer? Deo is for short term. You know, perfume has fragrance, right? Very strong fragrance it has. And it can diffused like in a second. If you have applied some perfume in one room, it gets spread all over the home, right? But in deo, it doesn't happen. It is the solid form, like it is in the compact form. We can't say solid form, but yes, their particles are more compact in comparison to perfume. It's a mixture of liquid and gases. It is also a mixture of liquid and gases, but it is in very compact form. Their particles are not that loose. Or have you seen the powder also, no? Powder does the same thing. When you go close to someone who has applied powder, you get the smell of that powder. But in perfume, it doesn't happen. You can smell it like from the other room as well. So it is the difference of the arrangement of particles. Okay. So diffusion happens majorly in liquid and like it spread, like mixes easily. Solid also shows a diffusion, but in a very slow pace. Okay. So we are going to write a relationship of diffusion among different states of matter. And please understood or write those relationship very clearly because some of the question might come from this relations only. I am raising this one. Even the incense stick is also an example for diffusion, right? The fragrance can spread in second. Now, here you have to write, hope you have written this property and then you have given the heading of diffusion where you have written the this definition and the statement which I have told you. Now continue from there. You have to write diffusion can take place in gases, liquids, and solids. Diffusion can take place in gases, liquids, and solids, though it is fastest in gases and slowest in solids. And then the next point you can write energy, because we haven't mentioned the energy one. Energy possessed due to the motion of particles is called kinetic energy. Write this much, then 2 points more I have to give you. Yes, Om. Diffusion is slowest in solids. And please tell me if you are not able to understand the word, because I'm writing on this one, so it's just really difficult sometimes to write it. Now the major point I'm writing here at the top, okay, students? Can I erase this one?
Yes, ma'am.
Okay. Now, so This is the most important point which I'm going to write. This is higher temperature increases the kinetic energy. In short, we write it as K dot E of particles causing them to move faster and thus increasing the rate of diffusion. So simple terms, temperature is directly proportional to kinetic energy and kinetic energy is directly proportional to diffusion. Temperature will increase, so everything will increase. Kinetic energy will increase, diffusion will increase. Star point this. Now, who will tell me? I am saying higher the temperature. How can we make the temperature go high? What does that means? What is referred to as higher temperature? Please write the point very clearly. You are boiling or when we provide heat to certain matter. We are increasing the temperature. So, students, can you give me any example related to this one? One example and then we will end the session. How can we say that when we are increasing the temperature, diffusion increases? Vapors. But how come diffusion? Like, diffusion is a part of vapors. You can observe this example as a vapor example, Abhay. Please give me an example which you can observe. So everyone, I just want you all to guess the experiment or guess the example for this relation and we will meet in the next class. I hope you have written this one. Shall I raise it up? Yes, okay. So we will meet in tomorrow's session again, okay? Till then, keep guessing the example. I will ask you all. Okay, thank you very much. You're going to, okay.